People online, maybe you can hear us now. Cool, okay. So what you just missed was Professor Anirban talking great things about me, how I'm a good researcher, and I'm coming in trying to talk to you about this course on recommendations today. So good morning again. Hopefully you can hear us online as well. My name is Rishabh. I work at ShareChat up until January. Actually, I have a slide on that. Basically today, I have a very selfish goal. I'm gonna walk around a bit. I'm gonna talk fast, talk slow, take a step back. All of those things will happen. I'm getting distracted by me watching myself over there, so I'm going to try to get adjusted to that in like 5 minutes. But we're going to talk about like learning from user interactions in personalized recommendation setting. And I think like one of the broader goals I have today is to try to pitch not just to the students, but also to the faculty members on the kind of industrial machine learning problems we deal with and the kind of focus we would also want to have on a collaboration from the industry academic perspective. So yeah, very happy to be here, and kudos to Devdut, who was the ex-VP at ShareChat, for putting us in touch with Shaurya and Professor Anirban and helping this set up. Cool, I'm gonna start talking about myself in a very narcissistic way, if this works. It doesn't, give me a second. It works now, yeah, cool. So currently I'm leading the feed and marketplace efforts on ShareChat. So ShareChat is a bunch of 2 applications. We're gonna talk about that in a bit. Up until January, I was with Spotify. I joined as a research scientist and then transitioned to the engineering team to own the production traffic. During my time at London, I did try to start something, usercontext.ai. Nothing happened. Like we got some paying customers, but then like I got a good offer from Spotify. I moved. Before that, during my PhD, I was doing a lot of work with Microsoft Research at Redmond, in New York, in Cambridge. I mean, literally everywhere. Working on Cortana and like user interactions, search, some of those things there. It's going to be chat. I'm going to happily ignore the chat for a while and come back. Again, I did my undergrad from this Pilani campus and very similar setup, like very green campus, a village outside. So even for a McDonald's, I had to wait for people to come in from Delhi. I think in generally, I'm very interested in the machine learning for recommendation systems. And I do realize that I have a huge bias of looking at the slides right now, I think, and not the audience, which sucks. I'm going to try to get used to this. But essentially, I've been working on personalization and user modeling for a while now, and even at Spotify during my time at my PhD. Most recently, I'm very bullish on the creator ecosystem entirely. And this is what I'm spending the next 4 or 5 years of my research career on. Actually, 4 or 5 years might be a bit too much, at least 2 or 3 years. And I think the goal over here is that how do we, I mean, a lot of the companies now are kind of focusing on the creator economy. If you look at Uber, if you look at Instagram, TikTok, Moj, even on LinkedIn, right? LinkedIn wants you to become, Substack. So a lot of the focus now is how can people earn money, not just from the day job, but also by doing something which they like. So the creator economy focus is kind of getting big in the industry. So how do we start looking at these machine learning problems for these marketplace platforms and creator economy? That's something which I'm very interested in. And you're going to start seeing some of these when we kind of talk about this. Currently, I work at ShareChat. And ShareChat is an AI-powered content ecosystem, and we are operating in 15 different languages. And I think I'm going to go slightly detour, slightly political note on something which I'm observing happening in the world. And again, anything I say for the next 2 minutes is totally unofficial, and I don't represent any company's view on this. One of the reasons, right, which I look at ShareChat and companies like this is that you have the world in geography, and then you have these like national boundaries wherein you have to, if you have to travel somewhere, you'll have to take the visa, and like these geographic boundaries separate countries. I think language is the corresponding boundaries on the internet. So we don't have like physical boundaries, we do have like language level boundaries. But also what's happening is like, if you look at what Twitter and Facebook did with Trump, he was a sitting US president, he got deplatformed from these big platforms. a couple of years ago. And these companies had a US CEO, right? So essentially, if the US sitting president can be deplatformed by the US CEOs of these companies, now imagine how worried the national states would be across the world, right? If it's happening to the US president, then like each of these regions, each of these countries will be worried. Now the question then becomes what happens next, right? The way I see this evolving is we are starting to see maybe national stack pop up rather than everybody relying on US companies or on like central companies across the world. I mean, you do see that like India, the entire financial system on UPI is heading towards a national finance stack for our own. We have shared chat. If you look at China, right, we have like WeChat, there's no YouTube, there's no Google, there's no Facebook, right? In Russia as well, there's no Facebook, they have VK. So I think like, but again, the problem then becomes that not all companies can have a social network of their own, they're not big enough. So then maybe they'll cluster together like Middle Eastern countries or South Asian countries or European countries. If you look at Europe, right, a bunch of 15, 16 countries, different languages, each of them having maybe like 100 million, 60 million population, not big enough to create a network of their own, but then like big enough to accumulate together, right? Now, this is exactly what's going on in India. I mean, if you look at the 15 languages we operate in, the content, the recommendations are all very different. The user expectations from Hindi users versus Gujarati users versus Tamil users, they are different. The content sourcing, the creators are different. If I create in Hindi, I'm not going to create in Tamil and vice versa. So how do these companies, I mean, it's hard enough to operate one recommendation system, but imagining doing that for 15 recommendation systems, right? So I think this is one of the key problems which I found like ShareChat, even before I joined, right? I mean, doing really well on understanding and focusing. So I think this is a right direction for us to think about, like, how do we become, I mean, again, also, right? There's a lot of like Indian culture in our current social networks, but none of the content which I see on Instagram, on TikTok, on Facebook are catering to the Indian culture or the Indian content entirely, right? So we don't have that local flavor, and that doesn't scale well. How does that play out? I think it plays out by having companies which are dedicatedly focused on looking at the local culture, looking at the local content, and then getting this onto the platform. So this, I think, is something which ShareChat is trying to do well. And again, this is just my own personal views. If you look at the community size, like we have close to 150, 200 million monthly active users, 50 million plus creators, and same for Moj, right? So Moj is a short video platform. So when TikTok got banned, we kind of were able to launch it like within 30 hours. And now it's one of the biggest short video platforms across the world. 50 million, I mean, this is outdated numbers, close to 200 million plus monthly active users here as well. So what's happening, right? I mean, you start seeing that these Indian homegrown companies surfacing recommendations at this big traffic space. So I think there's a lot of like good things going on in these things, and they are also related to my marketplace goals. And I'm gonna come back to this in a few minutes. So that's the background, that's me, that's my company. And I think that's the end of everything promotion I have to do. But essentially now let's get to the meat. What we're going to do is we're going to have a very dense presentation. I have close to 300 slides for whatever 4 hours. We're going to have some takeaway messages in between. I'm going to assume that people will kind of maybe on phone calls, they'll kind of zoom out, zoom in, sleep for a while. We will have takeaway messages in between. So if you kind of sleep for 15 minutes, I will bring you back onto the train and then you can carry forward from there. The work we're going to talk about in the next 4 or 5 hours should be applicable to a broader industrial setting, not just recommendations, not just for this company, but I think try to view all this content from a broader perspective of these digital platforms. The slides are going to be available on Discord after this, also on Twitter as well. Cool, so that's the course, Personalizing Recommendations at Scale. I mean, which is a different way to mention the first title I had, like learning from user interactions. So we're going to talk about some brief introductions. We are gonna, sure, that's fine, Aditya. We anyway can or cannot see you, so it's good. So we're going to talk about multi-stage recommender systems. We're going to talk about some machine learning approaches. I'm going to start then talking about how do we learn from user interactions, and then talk about evaluation. What we're going to do towards the end is, I was talking with Preetam about this. We have a notebook. I have a couple of notebooks. I'm just going to mention that provided, but then I'm just going to use that as an outline to talk about the industrial challenges at scale which we see. That should give you a flavor of what kind of infrastructural issues, what kind of ML operations go behind the scenes to get these systems to work. Cool. So again, I think like we'll see where we land by the lunch break. I think I'm hopefully aiming to cover the first 2 parts and then rush through the second part in the after lunch. So again, no points for guessing, but again, this is one of the pages at Spotify. Quick question, like, can anybody guess how many music tracks would there be on Spotify? Any guesses? Total number of music tracks across the world which are available on Spotify in general, in the world as well. A million? Okay, 1 billion is the answer. That's way too less, more. Also, people online can also kind of start typing in if you have an answer. 20 billion, no, that's too much. No, I mean, 20 billion is too much. Also, you can speak up, right? I mean, like you're assume you're in a class, right? You can just kind of unmute yourself and speak up as well. 20 billion is too much. 1 million is too little. Any other numbers? You're not allowed to answer now. I'm going to give you a chance in 5 minutes. Somebody else? 10 to 15 billion. Okay, even further. Last chance. 45 million? 25 million? No. So, okay, even further, more than that. You had an answer, you had a number. 35. Actually, the answer is 80 million. So we have 80 million music tracks on Spotify as of January when I quit. Again, like maybe it's 80 point some million now. So 80 million music tracks, right? I mean, on an average, I would have streamed maybe a 500 to 700 to 1,000 tracks. The remaining 79 million tracks, right? They're all discovery tracks to me. Now, how do the system know what music to recommend from this big catalog space, right? That's the recommendation problem. This is Netflix. Again, taking a step back. I mean, again, okay, I'm going to talk about this here. But if you look at Netflix, right? Netflix, when you go to the homepage, you're not telling Netflix what I want. And when you go to Google, you're typing in a query that, hey, Google, I want this. Like there's a search. The Google can look at the query, understand the user intent. On these homepages, we never tell what we want. So the goal of the platform is to understand the user intent and make some recommendations there, right? So intent understanding without any query is a big problem. What's the space of movies on the world across per language? I mean, what's the range comes to your mind? Everybody's allowed to answer, including you. How many movies exist approximately on some of these platforms? Sorry. Less than audio files, of course, yes. I mean, great point, like it should be less than audio files, but any number? 40 million? No, it's not in the millions, it's like way too less. I mean, because movies, I mean, music is like 3 minutes long. Movies is like, music is also like maybe one or two singers, a small team. Movies takes a lot of time to produce, right? So how many? Close enough, slightly more than that. Sorry? Sorry? According to Google. Nice. I like this. Sorry, what's your name? Dipesh. So Dipesh is smart enough to Google. I don't know why you aren't Googling, right? You can just kind of Google and find it out. So 50,000 is the number I have, right? I mean, not just on Netflix, right? But if you start looking at Hulu, if you start looking at other platforms, so 50,000 is the space of movies which we have. So again, look at the difference, right? 80 million music tracks, 5 million podcasts on Spotify as of today, and close to 50,000 movies here. This starts and stops working. This is Swiggy. So how many of you have used Swiggy here? Nice. I love it because I mean, I was in London, my family was in Lucknow. So during the pandemic, I tipped a lot of the Swiggy delivery partners well. So then they know that if there's some delivery there, they're going to get some enough good money on delivery tips. But I think like, I mean, again, one of the problems here is that there's a lot of restaurants, there's a lot of dishes. And what Uber Eats or Swiggy wants to do is like, they want to showcase the right restaurants to you so that you can order. Again, I don't have an answer to how many restaurants are there in Gujarat or in Ahmedabad. But again, you start seeing that this number also varies by the city. Books on Amazon. This is social media. Now, this is something very interesting, right? This is look at my Twitter. Sorry, my Instagram. I do have a pic of a cow which I took on my Instagram. So again, you can follow me there for animal pics as well. But the space of content in these media platforms, right? I mean, Moj and Instagram. I mean, this is like what? Okay, movies is what? 50,000 overall. In per language, Spotify music catalog, 80 million tracks. Here we get like 40 million content per week, right? Because short videos, 30-second videos, 30-second clips, images, very hard, very easy to generate. And the content, like if you look at the stability of the content space, the movies are here for a while. You still listen to 100-year-old or 50-year-old music, but then you don't watch a 30-day-old short video. So again, the content catalog space is different, right? So the recommendation space changes very, very rapidly. At Spotify, I could develop long-term user profiles, long-term representations of content. But here, I mean, I really need more short-term aspects in my recommendation problems here, right? So again, you start seeing that some of these content catalog, the size, the duration, the stability, they're all nuances. I'm not just going to talk about at high level. I'm going to come back to very specific points on how they influence the machine learning you do. Pinterest. How many of you use Pinterest here? Cool. So again, a large amount of pins over here, right? And again, the space is changing, but then like there's some stability in the content space. If you're kind of planning your wedding, if you're decorating your house, you kind of have that pin board around these things, and you're going to organize that information. One of the things which I want to mention, I added this slide earlier today, was this point which I saw on Twitter yesterday, and I wanted to emphasize. I see a lot of people on Twitter from the NLP community, from the ML community, all the ICML and all those people, they're very, very pro ML. What does get missed out is the impact on recommendation systems, right? I think Rexes are arguably the biggest and most important deployed machine learning systems in the world right now. If you look at any of these companies, like Netflix, 83 billion valuation, Booking.com, 72 billion, Airbnb, 60 million. And again, I'm not even counting the big 4 or 5. Apple, Microsoft, Google, all of them are doing recommendations. Even discounting the top 5 valuation companies, and this is current valuation. 2 years ago, this was like 2x, 3x this valuation. So again, you start seeing like $1 trillion companies in total are relying entirely on recommendations, right? And the time span of the users is huge. So I think like if you start looking at machine learning, especially in a summer school like this, you start reading about these things, but then these things are actually in production in a lot of these companies, and the entire production traffic is heavily, heavily reliant on recommender systems powering this. So again, huge world impact on these systems. And I think like when you start looking at Rexes, right, recommendations, you should look at it from a deployment perspective as well. It's just machine learning for ML sake, but then like a lot of user experiences, a lot of like billions of minutes per day are spent powered by some of these systems. Again, one of the things which I'll mention and then start going to specifics would be, if you start looking at some of these companies, this is not just about users anymore. If you look at Spotify, Airbnb, Uber, ShareChat, Zomato, it's about other stakeholders, right? And the other stakeholders could be the user, could be the artist on Spotify, could be the drivers you have on Uber, the host you have on Airbnb. It could be the delivery partners or the labels, delivery partners on Swiggy and Zomato, labels on Spotify, and the platform economics itself. I'm not going to discount the role the platform economics plays, because there's always strategic content, and as a platform, you have to sustain, right? If you look at a good supply demand world, if you have enough supply, then only you can sustain the demand, right? So I think these companies have to exist, they have to earn money, and they have to get the right ecosystem balance together. So it will be very important for the platform to sustain as well. So when we start looking at how do we power these systems, right? It's not just the user we have to care about. We have to start caring about all the other stakeholders as well. And that motivates the need for some multi-objective machine learning modeling here. So again, all of this is the background we're going to start using later on. The question then becomes like, how do we do this, right? So what exactly is the recommendation challenge? I mean, in all of this like large high level view, what exactly is it that we are trying to solve here? So the core challenge is very simple, that I have a bunch of content. I have a user. I don't know what to recommend, right? At Spotify, you have 80 million songs, 50,000 movies on Netflix, close to 120, 40 million per week active content on these ShareChat, mods, Instagram. Now, which content do I show? So that's the key problem. If you have to distill it down to one specific problem, which I hope you don't end up doing, you're going to be like, okay, if I have a user, if I have some content, what's the score for this user? What's the probability of user liking this content? You can get that for a bunch of different content. And yeah, and then the question becomes, if you have these scores, then you can pick the top 10, show on the homepage. So this is the high level problem. This is the one point we're going to keep coming back to. And again, this is something which even hopefully a first year undergrad can now start doing, right? If you have a user, if you give me content, I'm going to do some scoring. I can just give a random score between 0 to 1 for all I care. But the question here is one point, which is, this is scoring each user with each item. We call it a point-wise model. You can do an entire list that, hey, how is this entire list for this user? Is this a good list of 10 or not? That's the list-wise problem. So again, later on, we're going to start seeing the point-wise and list-wise differences. So that's the key problem. But then if you start zooming in, right, then it's not as simple from a one score perspective. You have a lot of nuances here. So one of the nuances is like the content space, right? What do we know about the content catalog? And I just mentioned briefly that the content space, the stability, like old content versus new content, the amount of content available, all of those are challenges in my recommendations problem, and which you have to care about. Users, what do we know about the user? Like, do we know that you like new music, you like old music? Are you open to like rock or hip hop? Or, I mean, are you okay with like looking at niche? Maybe there's a ghazal singer from Lucknow who you may be interested in, may not be interested in. So there's a lot of predictions. A lot of predictions we make, right? If you come on to any of these platforms, you're making tens of predictions. Like, are you going to stay back? Are you going to like quit? Are you going to abandon the session? How long are you staying back? If I know how long are you staying back, then maybe I don't show ads right away. If I have you for 30 minutes, then I can space out those ads. If I have you for 5 minutes, then maybe I'll try to leverage that, right? So essentially, each of these companies are making multiple predictions the moment you log in, right? And so again, understanding that user, developing these user representations profile, learning about the user, all of these are important topics, which we'll cover in the middle of the course. Other content is like, what do we know about the current session? What's the context? Like what you want today? I mean, people commute in the morning, so they listen to a podcast then, the behavior different changes over the course of the day and over the weekends as well. Now the question then becomes, with this context, how do we pick the top K recommendations as a problem? Now, if we picked up the top K, how do we show it to you? How do we find out whether this is good or not? Did the user like it? Are we doing okay? What are the dimensions of evaluation, right? One of the things which we'll touch upon later would be, you don't have to just evaluate on, is the user happy? Maybe the user is happy, but one Swiggy restaurant is not getting any attention from your model at all, right? So if you're Swiggy, if you're Zomato, or if you're Spotify, right? Or if you're like ShareChat for all, I mean, any of these companies, right? You have to make sure that the entire the supply space is represented. And if you have, I mean, again, evaluation, so far, when you think about evaluation, most of the industrial thinking is user-centric evaluation, which is bad. Because it's not just about making the user happy, but then maybe there is a small set of restaurants which are not getting surfaced on Swiggy at all. Those people are not earning money today, right? So the delivery partners, maybe some delivery partners are overburdened. Some others are just waiting that, hey, maybe I'll get a ride, right? So again, this is happening in the real world as well. There's maybe some auto drivers who are getting a lot more attention, or some are not. But then, like when you're designing these platforms, you have to evaluate on not just the users, but also on the other stakeholders you have as well. Now, again, this is where like not just stakeholder, but content, right? I mean, health of content, health of your platform. Are you just kind of going in for the clickbaity stuff? Or are you actually encouraging good content, educational content, infotainment content on your platform, right? I don't think anybody in the industry is like starting to develop these metrics just yet. Like, what's the health of the content which I show on my platform? I can get a lot of engagement by showing a lot like these prank videos, right? But is this the right long-term perspective for me to have? Do I want to grow my distribution, my consumption behavior in this direction or that direction? I think as a company, we need to take a step back, look at where we are going, and then have some informed bets on, hey, this is a nice content. 2 years down the line, we want to be masters of this content versus other. Again, taking a step back. Evaluation on the user, evaluation on the stakeholder, evaluation on the content as well, right? So multidimensional evaluation. User interactions, like, okay, you come onto the platform, like, 300 million plus users interacting on ShareChat every year, every day, every month. How do we learn from them, right? And again, like, I mean, it's like this. I gave you a homepage today on Spotify. You didn't like it. Tomorrow you come back, you do expect that, oh, you should have learned, I didn't like it, why are you still showing that to me, right? It's like, I give you a dish today, it has 30% sugar, 40% salt, you hate it, you're like, hey, I'm cutting on my sugar, so next week I should learn and reduce the sugar content in my dish, right? So how do we start learning about users at scale across the 100 millions of users we have? The question then, all of this becomes, hey, it's not just a problem for solving from a theoretical perspective, but how do we do it at scale for 400 plus million users, for 50 plus million content? The last, most annoying, most interesting part is, how do we do that in 100 milliseconds? You go in, if the homepage on Spotify or ShareChat loads, even if you see a slight change, right, 200 millisecond change, people get annoyed. Bing, back in 2009 or something, they did an experiment wherein if they increase the latencies, the return rate of the user, the ad revenue kind of dropped by multi-millions. We're starting to do some of these same experiments on ShareChat. Like, The moment it takes a fraction of a second more to load a video, right? Then you start seeing that friction, especially in 2020s, right? 2010, maybe the internet wasn't good and people had this expectation different. But now I have to do all this, right? Now imagine there is like 80 million content space, right? You come in, I have to learn about you. And again, not just you, right? Maybe 10 million users concurrently active at the same time. I have to look at that content, find out some information, make some predictions, and then decide the ranking, show that to you. All of that within 100 milliseconds. How does it work at scale? So again, you can spend 10 years solving all of this, and then another 10 years solving just this, right? So again, it's not just the recommendations community where it has advanced, right? I mean, NVIDIA, a lot of these companies are developing these powerful inference models. We talk about model distillation in the machine learning world. Hey, I have a big neural network. Can I distill it into a smaller network? Why? Because the inference speed is reduced, right? So again, like all of these problems become really important the moment we start talking about deploying some of this. So that's the complexity, right? So again, I did mention that, hey, it's all about scoring a content for a user, but then there's a lot more to it because there's a big background on where this is happening, when this is happening, and at what speed. Yeah. Yes. Right. Yeah. I think like great question, right? The question is like, I mean, we talked about top K recommendations, but then is it just about top K or is it like some notion of diversity as well? I think there is a notion of diversity. There is a notion of familiarity, discovery. Again, like it's not just, if you go to Spotify, right? I mean, if it's just a music catalog, then you can go to Apple Music as well, right? But then at Spotify, you know that the system, I've interacted with the system for 10 years. It has a user representation. It knows my taste better than somebody else, right? So I think like, can a system facilitate good discovery for you? I mean, this is exactly what some of these short video platforms are doing, right? I mean, such an insane intelligence on in-session personalization. You go to Mosh, you go to Instagram Reels, you go to TikTok, any of these companies, because this is an academic thing. I suggest you go to Mosh, but then regardless, right? Whichever app you go to, you start looking at some videos, maybe you start liking a crypto investment video, right? Suddenly, right, in the next 30, 40 seconds, you start seeing more of these, right? So there's an in-session learning going on, in-session personalization going on. We have 3-4 slides on in-session personalization later. But again, there's a lot more to it, not just showing a static 10, but then like, can I learn on the fly and like improve my recommendations? And again, doing that, not just keeping you in mind. Maybe it's fine, I'll kind of make you happy, but at the same time, if I can surface a tail supplier, a tail creator, then the entire list becomes of high utility for all my stakeholders. So that's the multi-objective aspect. So again, one of the things which I want to mention last, this is one of the, yeah. Yes. So I think the great question. When we talk about top K recommendation, then are we looking at a generic top K or like surface specific top K? This is a very timely question, as if you predicted the next slides, because this is exactly what I'm going to talk about in the next 30 seconds. One is that if you look at Spotify, right, or any of these companies, it's not just one recommendation system giving you one list of top K. It's every touch point is a recommendation surface, right? Look at this. You have some playlists. Now, different playlists will differ in the listening patterns. All Out 80s. All Out 80s is a playlist about music from the 1980s. Now, this is where a lot of very good tension between content personalization and user personalization pops up. Now, All Out 80s would be something very different for Professor Anirban, because he would have been around for a few years then, right? Some of you were like in your previous life. Again, I was born in the 80s. I'm not going to tell when. But again, the 80s for me is very different for the 80s for you, right? But then for a Spotify editor, they have a sense of what I'm creating this new playlist, new brand on All Out 80s. What is this All Out 80s about? It is about nostalgic music from the 80s, right? But then you start seeing a difference. The editor, the content creator has a view of what this should be about. The user has an expectation of what this should be about. Now you see a tension between this, right? If I just go ahead with what the editors want, then I may not personalize well. But then if I personalize too well, then maybe I destroy the original content hypotheses. Maybe you're only, as a user, you only like new music or fresh or trending music, right? So then like, if you only like that, then I don't want to make All Out 80s about that to you. Why? Because I mean, there is a content hypothesis which I want to respect. I don't want to destroy that just because you want All Out 80s to be about popular music. If you want popular music, go to other playlists. That's about popular music, right? So you start seeing that there's a lot of tension, even when you're designing the ranking of these playlists, there's a content hypothesis, there's user personalization, and then you balance the two. If you start looking at different media types, you have like charts. Charts is easy, like sort by popularity. That's the simplest recommendation systems you can develop. But then like you start looking at new releases, videos, podcasts, all of these are very different. New release, there is a fresh finds playlist on Spotify. Now, each fresh find is very different, right? Because which is the new artist you want to get exposed to? I mean, not just this, right? Product hunt or any of these new product or any of these recommendations wherein a lot of new creators, a lot of new products are coming up. Then amongst all of them, which is the most personalized set of things you would be interested in? So again, every content type has a different recommendation challenge to it. If you start looking at search, so search is something entirely different, right? Because you type in a query and then you expect some results, but also some recommendations. Search could be focused and non-focused. A focus query is like Ed Sheeran's this song, then you know what you want. Otherwise, it's like relaxing music. Now, relaxing music is a recommendation problem rather than a search problem. Why? Because it's a non-focus query, and you expect like, okay, tell me something. You know about me, use my representation, develop a personalized solution for me. If you start looking at the homepage, now homepage is a entirely queryless experience, right? Every company has a homepage, and there we kind of have to balance all these user intent understanding problems and do it at scale. And finally, you have these different moods and genres and other stuff, right? Now, what's my point here? The point is very simple. If you look at a company, you think that there is one recommendation problem here. No, it's not, right? Every touch point is a recommendation problem to the extent that there is something called taste onboarding. We do that at ShareChat, we do that at Spotify, which is the moment you come into the platform, we show you a carousel that what are the artists you would want to listen to, or if you're on ShareChat, on Merge, what are the topics you are interested in. Now there's a mini active learning system going on in there. I show you a bunch of artists at the start. You click, you select, oh, I'm interested in Sonu Nigam, I'm interested in Palash Sen, and I'm interested in Ed Sheeran. Now I still have the entire real estate. Like, I mean, you click on these 3 artists, I can change the other artist suggestions there real time, right? And then, oh, you see some other genre, some other artists, you click on them, you spend maybe 10, 20 seconds. But in that 10, 20 seconds, I've had a 3-way conversation with you. It's not just a static list I've shown to you, right? I saw your initial engagements, I immediately adjusted, and then I showed other, and then I could extract a lot more from you, right? So there's a 3-level conversation happening just on the onboarding, and there's active learning going on in there, right? So again, this again is a recommendation problem, right? So again, when you look at a company, it's not just one recommendation model and that's it, you're done. I mean, we don't hire like hundreds of people to do one problem, but each of them have a nuance of its own. What it means is each of them will have a team of its own, have data pipelines of its own, have models of its own. The search would be more of a learning to rank setting. The other could be more of a exploration, exploitation, bandit style setting. Different problems deserve different formulations, right? So this is the main point, right? I mean, you look at Swiggy, you look at Spotify, you look at ShareChat. It's not just one recommendation model, but then like understanding your product surfaces, understanding the user expectation, and then formulating the right problem, and then going and kind of acting on it. Cool. Yeah. Yes. Yes. So great question. I think the question is, I'm going to repeat all the questions so that people on the online also hear it. So the question is like, what's the role of human experts in this world, right? I mean, we have these fresh finds, we have these new releases. So what's the human element here? So I think like this is where, I mean, I did not realize it until after my PhD, the role of humans here. We keep talking about, I keep attending conferences, people talk about human in the loop AI, right? That's a fancy word to me. It was until 2017. At Spotify, we hire paid editors who are experts in the music, right? Again, I'm developing the homepage recommendation model. I have no clue what Gujaratis want, right? Maybe you guys have some weird or niche interest. I mean, not weird. I'm in your region, I cannot call it weird, but you have some niche interest. You have some, I mean, on ShareChat, you have different festivals, right? Now, different festivals means that I have to make sure that that content is there, that content is relevant for you. And again, cross-religion, I don't want to be showing cross-religion stuff because of the political debate it'll throw up. Now, how do I understand that? As a human, as a model developer, I cannot. I need that local editors, local content. There is a term. At Spotify, we have these editors, right? So who understand the local music culture, who understand on ShareChat, the local, maybe the festival culture, right? So all of that means that there's a lot of behind the scenes curation involved. And I mean, again, there's curation on the fresh finds as well on Spotify, right? I mean, which artist is the upcoming artist? To the extent, and I'm off the record, again, this may or may not be happening, I don't know, but allegedly there are news that some editors in the US have had artists who would pay, they live in a region, they have their homes here. So there are these advertisements on the road, right, on their way from their home to the supermarket, which are specifically advertised by that artist. They know that there's an editor who owns some of these playlists, right? If you as an artist get onto that playlist, then you get a huge exposure, right? I mean, these playlists have like millions of followers. If you are in one of these playlists as an artist, I mean, you go vertical, right? So then there is an incentive. I know that which editors curate this playlist, I can just go around their houses and start kind of maybe in the malls or in the grocery stores near them, start kind of showing my music or playing my music in the background. Maybe they'll discover it, right? I'm not saying this happens. I'm not saying this doesn't happen. All I'm saying is that these things are possible, right? So the humans do play a very critical role in this ecosystem. Yeah. Right. 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 Yes. Right. Right. Yes, great question. I think like I'm going to pick up the second example you gave, which is like, what if there is a strategic content on Moj, on Netflix, on Spotify as well, right? So there's always this strategic content, which is like Netflix has these Netflix original movies, like I mean, Moj and Instagram, they would kind of partner with some of these creators. The systems doesn't view it differently, because then you start. I mean, again, this is very platform dependent. I cannot say on behalf of all the platforms, but at least on the core, right, the system designers, we develop the system to be meritocratic. If the content is good, it should kind of surface on its own, get viral, right? I don't want to start acting like God and like making or breaking somebody's career, right? If you generate good content, then the system should start, there should be that feedback loop in the system, right? That, oh, I showed it to 100 users, they liked it, maybe I should show it to another 100 users, and then that circle goes on. So I think like from the systems I've looked at, there is no special treatment given to some of these content. But then what's the point, right? The point is that some of this content may not be on your platform, right? Maybe there is a lot of good content out there, but then nobody's creating that. So maybe I can bootstrap that category locally by pairing up with some of these creators and get that. Maybe there's no crypto investment video on Instagram on Moj, but then I see that there's a lot of appetite for it. So then maybe I can partner with some of these creators and get that content created for my platform. So yeah, cool. So that's the introduction. Again, a long introduction, and I'm way running out of time here. So we're gonna speed up even more. The introduction at least shows you the bigger picture, that like this is what's going on in the recommendations world. And hopefully by now I have your attention. I'm gonna do something slightly cleverish here. I love these two books, and they're pretty costly in India. I mean, at least if I were a student, they were costly. One of them is Personalized Machine Learning from Professor Julian McKelly at UCSD. It has a bunch of very, very interesting topics, a lot related to what we're talking about here. This is other book, which is Online Experimentation, Trustworthy Online Experimentation by Ronnie Kohavi, Yazoo, and Diane Tang. So Ronnie Kohavi is an industry expert on experimentation. And I highly recommend getting access to these books. I mean, the first one, there's a PDF available. What I'm offering is that, hey, I want you guys to post about this, post videos, post your thoughts on LinkedIn, on Twitter, about the summer school, about me presenting here. What I'm gonna do is the most engaged tweet and the LinkedIn post by the end of Monday will get a free book from me. You can pick which of these two you want, right? So the topmost post on LinkedIn, the topmost post on Twitter, you're gonna get one of these free based on your choice, right? And I'm gonna work with you on like getting it shipped to your home. So that's the deal, right? So the goal is like, look, I'm a social media person, and Spotify, Moj, TikTok, why not? So the goal is to take photos or talk about this on the media platform. And I think people who are attending remotely, they do have an advantage, because I would have just taken a screenshot of the slides and then created a thread on Twitter to talk about this. So that's the thing. I'm gonna keep reminding you in every session, right? Cool. So, okay, multi-stage recommendation systems. I'm gonna rush through some of this. I've already talked about that there's a lot of like 100 millions content available. Now, I cannot have a recommendation model because of the 100 millisecond latency requirement. I cannot rank these 80 million tracks all at the same time. I cannot rank these 130 million short clips at the same time. So for that, I need a multi-stage system. So the way it looks like is this. I have this entire corpus, and this is borrowed from a Rexis paper from YouTube. Very, very similar stuff at Pinterest, at ShareChat, at Spotify. That I have a candidate generator. The candidate generator is a light ranker. It says that, hey, I'm going to look at the entire content catalog for you as a user, and then I'm going to bring back a few thousands or maybe a few hundreds of content, right? So this is what a candidate generator does. That the ranker cannot rank 80 million tracks, 80 million content. So the candidate generator reduces the space. And then you have the ranker. The ranker could be your most favorite high capacity neural network or whatever you want. Why? Because the content space is reduced. I'm dealing with a few thousands. So then that means I can have more powerful neural networks or more powerful architectures for this. And essentially, I mean, yeah. So essentially, you have the context, you have the user history powering it. You also then have a bunch of features additionally, which you can consider in the ranker stage. Why? Because some of these feature calculations are very hard, and I don't want to be doing it and storing it for all the content I have. I can only do it for a few hundreds. So then I bring it in the feature stage. But there could be other candidate sources as well, like things like what's going on popular today, or maybe there's some other strategy content pipeline. So the ranker can start consuming all of it, and then that gives you the few dozens which you want to show on the homepage of your app. So that's the typical pipeline. I mean, the content space reduces drastically. We go from tens of millions to tens of thousands, hundreds, and then a few tens, right? So, yeah. Yeah, so yes. So the question is, at what stage does the personalization kicks in? So the candidate generators are personalized because there's a lot of user history and context. And again, I think again, it's fine if you don't have a personalized CG. CG is what we call like candidate generators, but then that's also stupid, right? Because then I mean, I'll randomly select music to you, and it may, again, it's not going to work well. So the important thing is it to be personalized, and then personalized in a way that can handle tens of millions of content as well. Great, yeah. Yeah, great question. I think the question is what if there's a new user, and then can we look at something like PageRank or other stuff to populate? I think for new user, typical cold start problem. I mean, cold start on content is a nightmare, which it's a living hell for me personally as an IC. I'm going to come back to that in a bit, but on the user front, right? Case onboarding is a big piece. The moment I onboard you, first, I mean, when you come to the platform, I ask you some questions, and then I get something, right? But even if I don't have that, I can maybe have some predictions, right? I have your IP, I have your geolocation, I have some context, right? Maybe you're using an Android device, maybe you're on a Wi-Fi, maybe you're not. So I think there's a lot of these signals which I can have, not about your taste, but about you as a user, and then I can start doing it. But this is where in-session personalization kicks in. I don't know anything at time is equal to 0, but then if I don't know anything at time is equal to 60 seconds, then I suck, right? Then because you've interacted on my platform for 60 seconds, that means at least 2-3 videos, right? So this is where in-session personalization, we were talking about this 20 minutes ago, that kicks in, right? So again, in-session personalization, we've had, I'm gonna give some free publicity to my team, Nilesh and Rohit on my team have worked on in-session personalization. And the biggest gains we saw was for new users. Why? Because we suck at new users. We don't know anything about them. So it's easier to kind of improve a bad system. So some of these personalization goals give you a lot more wins at the start because the baseline for new users is anyway much lower. But the important thing is the candidate generator is very personalized, right? So we're going to talk about a couple of candidate generators today. In the lab, which Preetam is going to somehow share with you, we're also going to touch upon a 2-tower candidate model. So that's what's going on. I think Nipun was talking about diversity. So this re-ranking is the diversity layer as well. I mean, it could be, it's not just about diversity, it is a bunch of other stuff as well, but then you can re-rank, yeah. Yeah, so I think the question is what kind of features does candidate generator take in? I mean, the videos I've liked, the subscriptions I've had, I think mostly the problem is that it can do a lot more, but then I think there's a lot of money which we intentionally leave on the table. Because I can maybe have a prediction about you, what do you want today? But then to have that prediction about each of the user and 80 million content, that's harder, right? So I think the easiest user interaction signals, which is like, what's the smallest set of features will give me the maximum coverage in the user space? That's what we're looking for here. Why? Because again, the scale is a problem. We are leaving a lot of money on the table in the CG part because I know a lot more about the user. I just cannot use it because of the 80 million content space and the latency requirement, right? So this is where you can pre-compute a lot of these features to store them and then serve them. So all that kind of, we'll talk about that later. Cool. So I think like what we've done, I said we are way behind on time. So what I did was I rushed through some of these in the next 8 minutes, and you didn't notice. But essentially what we're going to do is now talk about some ML problems here, right? I'm going to start talking about some traditional approaches. This is where like what you've been studying so far comes into play on matrix factorization, tensors, embeddings, and all. And then I'm going to talk about, okay, actually what is going on in the modern recommendation systems. So we're going to talk about the candidate generator, then we're going to talk about the ranking. So it's going to be slightly wavy at the start. We're going to, again, for the next few, I'm just going to one slide each, not go into detail, just give you a high level view, and then really go into detail of how modern recommendation systems are developed. Cool. So collaborative filtering, right? I mean, raise of hands who don't know it. Cool. Everybody should know it now, right? Yeah. So essentially, like, again, it shouldn't be a surprise to you. We have, this is Netflix challenge from 2006, $1 million challenge, wherein they were saying that, hey, give me the best recommendation for the user, and then I'm going to pay you money, right? So what has happened is like since then, like these matrix factorization techniques have really kicked off well. So we have a huge user base, we have the huge item space, and then we have a matrix which is sparse, and then I can decompose the matrix. The decomposed matrix gives me the user representation and the item representation. These are what we call the latent factors. I can store these, right? I can store for 80 million content, I can store these vectors. And this could be a candidate generator if I have, right? Because I have these vectors. If I can do a dot product for 400 million users, 80 million content, if I can do that dot product in a scalable way, then I have this as a good candidate generator. Again, how do you do that dot product across 400 million users at like 100 millisecond latencies? We're going to talk about that via approximate nearest neighbor search in the next 1 hour. But again, this is typically what happens. Now, the scale of this matrix is huge, right? 80 million content, that means 80 million columns, 400 million users. How do you do that? So this is what a lot of companies like Criteo who do, approximate SVD. I think like Professor Anirban was talking about SVD yesterday, one of the libraries. So what they do is like they also have an approximate version of this, which runs at very, very fast pace. So I can kind of maybe top up the message on Discord by adding a link to that. So there's like huge approximations you can do and like run that scale. Not going to talk about that in detail because that's not my point. But what we can do then is like, again, this cartoonish figure is a figure from one of the second papers I wrote during my PhD, was that if you have a matrix, right, then you can just extend that to a tensor. So a matrix will give you a two-dimensional view. What I can do is I can additionally incorporate like your location, your other tastes, your features. During my PhD, I was working on tasks. So I had a user, topic, task, tensor. And tensor is just an extended form of matrix. A matrix is two-dimensional. Tensor could be 3-dimensional, 4-dimensional, 5-dimensional, whatever. If you can decompose a matrix, you can decompose a tensor as well. Now this tensor is very interesting, right? Because here you have a big tensor of the user topic task, and then you can have the user term matrix as well. So you can have a matrix, have a shared dimension with the tensor, and then do a joint decomposition. And again, you don't have to do it. There are solvers which will do that for you. So as long as you're able to formulate your problem, you'll get a tensor factorization solver, and they'll give you these dimensions, right? What do you get out of it? You get much better latent factors, right? The previous latent factors you had were just on the interactions in the matrix. Now I have additional side information which I can leverage. So that means the information I have in the formulation is a lot richer, and I can get better representations. If I have better representations, I get better dot products. If I have better dot product, I get nicer recommendations for you. So that's a bridge. Then what happened was like there is something called latent variable models. How many of you here know what a latent variable model is? You don't? Cool. So there's a HMMs is one example of a latent variable model. The typical thing which people do is like way back in 2003, David Blee, Andrewing, right? I think like if I ask how many of you have listened to his lectures, I think you'll raise like both hands up essentially. So Andrew Ng was one of the authors. I think it was one of his first most popular paper, 2003, Latent Digital Allocation. This was talking about how do we extract topics. If I give you a news corpus, I don't know how many topics I have. Can you, I tell you K, give me K topics, and then it'll give you this K topics. I think the point over here is that you can have again, I know like Professor Nipun is around, so I mean, I don't want to attempt to describe these Bayesian models while he's in the room. I will not do that. Essentially, you can reach out to him. He'll talk a lot more about that in detail. But you can have these variables. Some of these are hidden. I don't know what the topics are. I don't know what the user preference is. So maybe I can create my entire network of variables and do some inferencing. Some of these are observed. Some of these are not observed. And there is a class of models like latent variable models, which will give you the right inferences. The good and bad thing about this is that the good thing was like now you have a lot good math to formulate your problems, right? I mean, I don't know. I mean, there are, let's say 10 genres in music. I have no clue which genres you would like. So that's the latent variable for me. What's your user propensity for this genre? I don't know. That's a latent variable. But then that will have an arrow towards whether you're going to like this or not, how much time you're going to spend. So you can imagine, I can start constructing some of these latent variables by just saying that, oh, I don't know what the user propensity for this genre is, but that I do observe how much time you spend on this music playlist. So then you can have an arrow from there and start doing inferences. So there's a direction in which you can go. The good part about this was that it was very, very rich in the early 2000s, even in the 2010s. And that's how a lot of PhD students were able to get their PhDs, right? Because you think of a new latent variable model, you can do some nice inferences, you can write some very math-heavy papers, and everybody's happy. You get to publish, and you get your PhD. Again, I'm slightly making few statements which may or may not be true. But essentially, like, I mean, a lot of work has gone here, but then there are like scalability concerns with these. Then what happened was Word2Vec came along, right? I think I missed a slide. There is no slide. Yeah, okay. So Word2Vec came along. So I think like everybody now should be knowing what Word2Vec is, right? Does everybody know what? I mean, I think here I'm looking for recall. Does anybody not know what Word2Vec is? You don't know. Cool. Nice. As long as there's one person I can speak. So Word2Vec is in 2013, Thomas Mikolov. He is now, I don't know where he is, but basically it is a embedding. Embedding is a representation learning approach. So Word2Vec is a neural representation learning approach, which will give you a vector for each word. So once I have a vector, I can start doing some of these calculations like a king minus man plus queen is equal to a woman. So if you represent each of these words as a vector, I can do vector algebra on these embeddings and then come back with the answers, right? So the way it operates is, it says that give me a few sentences. If you give me a sentence, I can pick up one word. I can look at the neighborhood words. Now the hypothesis is that words which co-occur together, they have the same neighborhood. They should lie somewhere closer in the embedding space, in the space of vectors you are putting in. Now, if you start doing this, right? I mean, you train it via negative sampling. Negative sampling is that I pick up a word, I look at the few words adjacent to it, right? So these are positive words. I want to bring them closer. I randomly sample some other words which are not in this sentence from my corpus, and I try to move them away from this current word. If you keep on doing that for all the words you encounter in your corpus, you will end up with a representation space. And that representation space is the embeddings which you use. So that's what's happened in the Word2Vec community. There are, I mean, 2013, you had the C++ code, you can run it and then get your embeddings. What people did was they put Word2Vec on steroids. At Spotify, one of the most hardest baselines I've had to beat was this word embeddings. Now, in a word embedding setup, right, you can do that for documents, right? You have a document, each sentence is a set of words. You learn the embedding of the word. What we did was we had playlist, right? And a playlist, you have these tracks, and in a document becomes a playlist. The set of words become a set of tracks. And I can now run Word2Vec on top of my playlist and get representations for these tracks itself. So that is a very, very powerful thing. And I think one of the very nuanced point over here is that these are very hard to beat. I mean, an embedding learned from this is a very, very powerful embedding. And I can guarantee that, I mean, not guarantee, but at least a lot of people can develop any fancy ML model, but then they won't be able to beat these embeddings. Now, can anybody try to guess why this embedding approach would work absolutely brilliantly? I mean, for Spotify, for like 10 years or something, like these were very, very powerful, very hard to beat. And I myself and a bunch of my team threw a lot of models to it, but then we were not, it's very hard to beat this. Why would that be happening? And the background is, I have a bunch of all the playlists which we have, right? So each playlist becomes a document for me. So again, like you have your English corpus, you can have news articles. I have the set of playlists which users have generated, created on the platform, right? So I mean, users have been around, Spotify has been around since 2006. I have a bunch of these playlists. Each playlist becomes a list of tracks. So each playlist becomes a document, each track becomes a word. I can learn this embedding. So that's what's happening. My point is they work absolutely brilliantly well, to the extent that you can develop any powerful neural network and they will be very hard to beat. Now the question is, why would that be working really, really well? And if a student offers this, I'm making a promise, I'll give you an internship for free at ShareChat. Because again, the nuanced answer to this is very nice. Maybe it's nice for me and trivial for you. Right. Sorry, I mean, I 80% hear you, I don't follow. Yeah. Right. Right. So why would it be? I mean, it's working great for, I mean, because English corpus, right? I mean, people have written sentences and like there's a lot of like content out there. I can train what embeddings on top of English corpus, and that's great, right? But why would it work so well in my track embedding space? Why is this? I mean, I can learn a separate neural model, right? This user, this track, predict whether they're going to interact and then learn from that as well. But why would this specifically Word2Vec style models work here? Like the why aspect. Yeah. Right. Yeah. Yeah. So basically, no. Yeah. So I think a clarification point over here is you have a playlist, right? So in Word2Vec, I have a doc, and in that doc, I have sentences. So that means like the sequence is a sequence of words. Here, I look at a playlist as a sequence of tracks, right? And then like similar, like a document is a playlist, a word is a track, right? So then I can start learning these embeddings by Word2Vec in a very similar fashion. So each track is surrounded by, each word is surrounded by neighborhood words in your Word2Vec. Each track is surrounded by neighborhood tracks in this playlist dataset. Also, if anybody has an answer online, please unmute yourself and speak up. Yes, it can find similarities. I mean, I don't have to define a similarity measure in a Word2Vec, right? I just give it, hey, this is a corpus, learn it. So I'm not defining anything specifically here. Right, right. I think you're at 55%. Yeah, but playlists similar. I mean, I think you're both now talking about playlists who are similar, going to be same in the vector space. But here the vector space is about tracks, right? So, I mean, I'm not representing playlists in a space. A playlist becomes a document for me. Yeah, I mean, the output of this is a representation for a track. So vector representation of tracks. I think if you speak a few more words, you might hit the answer. Right. You got derailed. I'll come back. Right. Right. Yes, but how is it related to the playlist data I have here? Yeah, I think now I think like if I combine the two answers, right? I think the answer is, and I think you both should reach out to me and I'll hold myself accountable to what I said. I think the answer is these playlists have been created on a platform since 2006. There's a billion plus of these playlists. Each playlist is created by a human. And that human, I mean, there is like Diwali coming up. I'm going to create a Diwali playlist. I'm going to spend time, find Ganesh bhajans, Lakshmi Puja bhajans, right? I'm going to use my brain, do the search, pick up the tracks, and then hand curate this playlist. Now imagine doing that across 10 years, across 400 million users. Now this data is the answer here, right? That the playlists which we have on the platform, right? I mean, they have been created by 400 million users across tens of years, and each playlist is a lot of like our own interpretations into designing and curating this, right? At scale is such a powerful beast. I don't need fancy ML models. If I have this access to this data of how humans think about music, I mean, a party music for me and a birthday music for my nephew, all of these become a playlist. I'll give them a title. There is an organizational information structure here. And then this is exactly why, again, that's the data advantage which companies have, right? Google search has a lot of the advantage that people have been clicking on the search results. So Google knows what is right and wrong for you. This is a Spotify's mode, right? That, hey, I mean, I have playlist data. You can have all the catalog in the world, you can, right? But what you don't have is this user curation on the platform, right? I mean, this is what Tesla has the advantage. Tesla has a lot of these self-driving cars which are generating data every kilometer, every mile they run in the US, right? So again, different companies, Waymo and all will come in, but then the data advantage is definitely there. This is exactly what happens at Spotify, right? I mean, we have these playlist data and we have these embeddings. The moment I have embedding, I can do a dot product. If I am a new product person, I don't have to develop any new ML model. I already have a dot product. I can just use that to, I can do the same for artists. I mean, I'll embed my users, my playlists, my artists all in the same space. And then any recommendation I have to do across my surface, the first model is a very powerful model. I don't have to develop a custom model because a platform team has designed this behind the scenes. It has made it available. So the default recommendation quality on the platform is far better than any other company out there. Why? Because we've had this 10 years more, 15 years of playlist data by 400 million users manually curate these playlists. So this data advantage is what Spotify has working for itself, right? Except for the brilliant people they end up hiring after that, including me, right? So that's what's going on, right? I mean, you have, yeah. Yeah. Yeah, I think the embeddings do have a semantic meaning itself, right? You can club them together, and the embeddings from same genres would be very similar. And not just this, you can have like these hierarchical embeddings as well. So again, like there are these, what is it, point care embeddings. Point care embeddings is a latest form of embeddings, which will have this hierarchy mapped in a much richer space. So I think like all of that semantics will play out if the embeddings are better. So that, I mean, you can do, I mean, we do a lot of like post evaluation. How do you evaluate whether this is a good embedding or not? I mean, even when you're training this model, right, you'll have different flavors of this model. So I think like, how do you evaluate these representations is a great problem. I didn't intend to spend time on it, but I'll spend 2 minutes on this. Now, if you go to any company next, right, I mean, one of the things you should do well is develop a common representation which everybody can consume. Now, this is the behind the scene information which you won't find in textbooks. And this is why this summer school is great. What usually happens is each of these companies has a separate, what is it called? ML platform or some team which doesn't care about the end user product. So the homepage people, the homepage team will care about how do I make the homepage better. The search team will care about search. The radio team will care about radio. But I need a set of people who can develop these generic user and track embeddings, which I will make available for everybody to consume. And intentionally, I will not care about how this is performing on home versus radio. Why? Because I don't want to be that person. I know that the home team will come in and start using it. But in the company, if you're setting up these data science units in your companies, then you would want to make sure that there is a set of people who are just improving your default baseline. The moment this embedding is better, everybody else across the company is better, right? Because they're all using their models. So suddenly like 10 teams using it, your core representation is better, then everybody sees an uplift in their metrics. That's one. The other advantage is maybe there is a new product, new surface. There, I don't have the ML team. I mean, the first engineer I'm going to hire is not an ML engineer. I'm going to hire a backend person, develop that for me. How are you powering that? I don't have an ML model. You're going to power that using this common representation. So if this common representation is good, the default recommendation quality from your first deployed model in that surface is far better. So this is like the behind the scene information that makes sure that there is some people in the companies who are just working on that, improving the default and then making it available. And you see a lot of like multiplying effect, right? You improve this embedding, everybody else sees again, and the new people can use a much better system as a default recommendation system there. So that's how, like, if you look at Netflix, Spotify, a bunch of these companies, there is a team which is just developing these platformization representations, making it available. This is exactly what's going on with Pinterest. Pinterest has an amazing, amazing graph neural network representation space. And what they do is like Uriel Escovic at Stanford, he now has a startup of his own. He was a chief scientist there. Pinterest over the last 6 years has done an amazing job in representing the entire users and pins in a graph, and then doing pin sage. Pin sage is a recommendation embedding extraction, graph-based embedding extraction technique. And there's a NeurIPS 2017 paper on it. You develop this huge graph of all users, all pins, extract the embeddings, store it. That's it. All the other engineers, ML engineers, can start using this base representation. And Pinterest recommendations are insanely good because the core representation module of these GNNs giving you these embeddings are great. So again, Pinterest has leveraged it to do a lot of good work. Spotify has leveraged it for these word-to-vec embeddings. So again, some of these default embeddings are so powerful that they can play a big role in the company success. Also, one thing I do want to apologize. I think there's a lot of content here which is not on the slides. So I think the people who are going to look at the slides, they're not going to get this. I mean, a stark difference which I'm seeing between like Spotify and ShareChat. Like on Spotify, the playlists are different, and hopefully like some people will have mixed language playlists, but most of them don't. Most of my playlists are very thematic. So then there's no language specific aspect in my recommendation models. So embedding architecture is the same. Everything gets represented in the same space, right? And I think to the extent that I'll even advocate, like the reason GNNs are great is because they are embedding knowledge graphs. So here, okay, at Spotify, at least like the team I was working with, we had these embeddings. I had to derive the user embedding using the track embeddings. I did not put the users in my space. I did put the artist here. So I can learn the embeddings for the artist and tracks, but not for the user. What Pinterest is doing and what we're trying to do at ShareChat is, can I put everything in a graph together? In that graph, everybody is a node. You are a user, you get a node. You are a track, a video, you are a genre, you are an artist, everybody gets a node. The good part about that is the representations are cross-compatible. I can do a dot product very quickly, right? Here, what's going to happen is I have these embeddings. I'll have to derive a user embedding. The user embedding could be an average of the last 10 tracks or the average of your tracks. Again, the moment there's an average, it's okay, it works great, but then like maybe there is a better way to do that. Yeah, the graph design is the choice, right? How do you design? When there's an edge between two tracks, or maybe people, on Spotify or on Pinterest, like maybe how many common boards those two pins have, right? So I think how do you design the graph is how you're encoding your domain knowledge, and then learning from that. Cool. Okay, I think this was a very unintentional detour, and we are way lagging behind. Essentially, what's going on is, okay, let me recap, right? What's going on? We did a detour. Good morning, wake up if you're sleeping. What's going on is we're talking about like traditional recommendations, right? Very simple vanilla recommendation models. We talked about matrix factorization, tensor factorization, some embeddings, and like word to vec, and then how people can use word to vec for recommendations. What people did next was neural collaborative filtering. So there's a nice WW paper 2017 which says that, hey, these matrix factorization give me good collaborative filtering. Like collaborative filtering, why? Because I had this matrix, this user like these movies, the other users like the other, maybe I can extrapolate. So that is what matrix factorization was giving you, right? I mean, you go back 3 slides, this is what we were getting before, right? That I know I've liked this song, I know you have liked this song, you've also liked the other song, so maybe that's a good song for me. So we are learning across users via this collaborative filtering approach. And we have seen great advancements on these embeddings. Now this paper combines the both together. So the way it does it is that I can still have the latent aspects, right? I mean, I'll have the user and the item and the latent aspects, and then I'll kind of combine it in a neural embedding world and then learn that. So this neural, again, I'm not going to go into much details because it's not entirely what I want to talk about. But essentially, this is combining the benefits of the embeddings and the collaborative filtering, and then training it end to end. That training it end to end is the key part. Any neural network which you can train end to end, that means the entire network is kind of getting better with each training example. Cool. So we are 20 minutes behind at least, but what's going on? What's going on is that I've done a lot of like English hand-wavy introduction about recommendations. I've talked about the multi-stage view, that we have a candidate generator, we have the ranker, and in the ranker, we've talked about what you would have done if you were not in this course, right? But because you're in this course, you want to do the state-of-the-art things. The state-of-the-art is to develop a better model for both the candidate generator and ranking. So my advice is not to pick up any of the stuff which I just talked about up until now, except for the embeddings, because the embeddings are global. Everybody can use them. But start focusing on what the companies are doing as of today. So what you're going to do next in the next 10 minutes is start talking about some of these candidate generators. We'll see where we land, and then you can go for the break, come back, depending on what the mood is in the room. Any questions so far? And my offer from a few slides ago still holds. I'm going to go back and highlight that offer of you posting online and getting at least one of these books. Cool. But at least I hope like the candidate generator aspect is clear, because we're going to heavily rely on that in the coming slides. So long story short, a ranker cannot work on 100 million content, but the candidate generator shares that burden. It's going to bring in from that tens of millions of content to a few hundreds, few thousands. So that's the goal of the candidate generator. Now, okay, this, yeah. Right. Yeah, exactly. Excellent question. I should have mentioned that. So the question is, like, earlier we were dealing with like 1 to 5 grading, right? In the matrix, like you rate that I like this movie 5 on 5, 1 on 5. Now the question is like, what's this? How is this getting operated upon? Are we still looking at explicit interactions? We are going to get to that later in some part, but the short answer is no, we don't deal with explicit at all. Everything is implicit. Implicit means that to the extent that you come on the homepage, how much time did you spend on the homepage, right? I mean, did you stream this playlist? If I'm showing you video on YouTube, like, did you like this video, or did you like maybe spend 20 seconds watching this video? 20 seconds on a 30-second video is great, but 20 seconds on a 3-minute video is crap, right? Now, again, like time spent, we call it at shared chat, we call it like video play, like stream time or dwell time, like on images. How much time are you consuming the image, right? So then if you're consuming more time, then that's great. I mean, you're liking it, you're spending time. The problem, one of the other nightmare problems is this dwell time signal is so hard to interpret. Like, let's spend 2 minutes on this. I think it's a great question. Thanks for bringing this up. I'm going to take a step back. Yeah. So what's happening, right? Videos and images. What's the signal? How do I know that the user is happy? On videos, I can see that either they will like it or comment on it, right? But maybe only 3% of videos have a like comment. Or they will stream. If they're streaming 80% of the music track or 80% of the video, then that means they're happy. If they're streaming maybe less, then okay, they're not happy. That's fine. I mean, it's slightly okay to work with. The images is what the hard problem is, because an image, I don't know, you spend like 3 seconds. Did you like it? Did you not like it? Or you spend like 4 seconds or just 1 second. The problem here is that, thank you so much. The problem here is like, I mean, if you look at some of this content on ShareChat, right? I mean, some of these images have Shairi written on it. So there's a lot of OCR text on the image. So that means you're gonna read the text and then try to understand and then say, oh, this is a crap poem, right? And I don't like it. Or this is a crap content, or I mean, you can do a lot of OCR text understanding from the image. And then if there is a good amount of text, then a 2-second threshold is not good. Why? Because it'll take 3 seconds for the person to read the text and then form an opinion, right? But then if there's a cute dog or a cute puppy image, right? There you don't have to spend 3 seconds. In a second, you will know whether this is good or bad. So one of the hard problems which we are facing, and we are hoping we'll write a paper on this, would be how do you detect satisfaction across these biases in the content space, right? I mean, like a lot of literature content, literature posts, right, has more text, right? I mean, so people are going to spend more time on cognitively understanding it and then form an opinion. But like these pet images and all that content doesn't have a lot of cognitive load, so people are going to look at it quicker. So the threshold you have for success, right, it should be higher for some of these categories and lower for the other category. Now again, this is a easy problem for me to highlight, but a nightmare problem for us to solve. This is exactly how search works. On web search, Google and Bing both have this feature. I know from Bing because I've seen that in production myself, which is that readability level of the document. What Bing does is that if you click on a document, if you go to a search engine, you type in a query, you'll get a list of results, you click on the result. If you spend 30 seconds reading it, search engine saying, oh, great, you loved it. You like the content, that means you found it relevant, right? So again, this is what search does. They look at the dwell time on the click document as a relevant signal. We don't ask people that, hey, did you like it or not? We cannot ask like 100 million users that. Now, the problem is the people which identified, like Ahmed Hassan, I was interning with him at Microsoft Research. 2015, they had a paper talking about readability level. Now, some document which is written in class 1 English, you will read that, understand it in 5 seconds, and then comprehend it. Some other documents are written in much fancy English, K-12 English, class 12 English, and then you'll take a lot more time to understand, comprehend it, right? So the readability level of the document is something which Bing predicts, right? I mean, each document has a readability level attached, K1 to K12. And then based on that, you're conditioning that, hey, the success time should not be 30 seconds for this. Why? Because if you're searching a good paper based on parametrics, then in 30 seconds, you can't understand whether this is good or not. So the success definition should vary based on content, right? So same for search, same for us. Like literature content has OCR text. Using OCR, you can find out the amount of text, and then you can condition the success criteria to be somewhat different. And then puppies or other natural images will have some other threshold. So I think this is what a lot of these practical problems which my team deals with on how do we train a model. You can train all of these, right? But I think the great question like Nipin brought up was, what is it that you're training it on? Like my answer is that we're training it on an implicit signal, but then how do I find out whether the user is happy with it or not? In videos, I can look at the stream time. If it's close to 100%, 80%, great. On images, I look at dwell time. Dwell time is up for interpretation. That's where the meat of the problem is. Can I interpret it correctly and understand, did you like it or not? Or you just kind of, yeah. Yeah. Yes. I think the great question is, so these are, I mean, these are immediate metrics in the sense that, okay, the question is like, these are immediate metrics, you get to know immediately, but then are there longer term metrics as well? Yes, definitely. The long-term metrics, and again, I think like you acknowledged well that these are harder to solve, harder to tackle. The long-term metrics is, I mean, I'll start. I have a slide later, but the point is that you have, the reason I keep saying I have a slide later is because I think I have a lot of slides, and given the speed, I don't think I'm going to get to it. So let's just cover it now. Essentially, I can look at the content. I can look at how you're understanding the content. I can look at, from this content, I can look at the entire homepage. So I go in from one point, one item. I can go at like, oh, are you liking the entire homepage? That means, are you spending more time? Then I can look at the session itself, not just the homepage, but then like, how long have you been active? So that's like, you go from an item, you go to a list, you go to a session. Across session, you go to, okay, are you coming back tomorrow? D1 retention. Then you go to, are you coming back next week? D7 retention. Are you coming back this month? D28 retention. Why is it important? D1 retention is DAO, daily active users. If you are in any of these companies, you get more money from your investors or from the stock market if you have a high DAO number. My mandate from my CEO, this is on the record on YouTube as well. So Ankush, if you're listening, hey, hi. But essentially, like my responsibility at ShareChat is to increase DAO. DAO is daily active users. How many users actually come back to my platform tomorrow? Right. So again, retention, D1 retention, D7 retention. At Spotify, one of the metrics which we were able to move was D7 return rate. Are people returning back to your playlist or not? Right. So, but again, the problem is I don't know how to optimize. What makes you come back tomorrow? How do I know? I mean, like maybe I can know that, okay, you like this track or you like this video because you engage positively. But then how does a bunch of these positive interactions across items in a session lead to you coming back tomorrow, right? So that bridge between short term and long term, this is not even long term. I mean, long term is subscription. Are you going to churn as a subscribed user in 3 months time, right? So then what do people do? They look at time to inactivity. So there's a bunch of nice papers on how long are you going to stay inactive for? What's the time between you coming back to the platform? There's a lot of work on survival models. So prediction models are fine. I mean, you can have a classifier model. Survival models is like, I mean, that's what people at good companies are doing, right? I mean, a new good MLE joins my team. The first thing they start working on is survival model. Why? Because I want to predict the probability of you surviving on my platform for another month, right? Not just that, right? That's not the state of the art. The state of the art is the change in survival models. I think I'm going to spend 2 minutes. I know I'm doing injustice to my course here, but I think you brought a very good point, which is very close to my heart. Now, just forget about what we are talking about, right? Just focus on this for 5 minutes. I think this is a very brilliant point, at least to me. Look, I mean, Spotify pays $100 million to Joe Rogan podcast, right? I mean, you were asking this question, right? Sorry, what's your name? Nimish. Yes. So Nimish was asking this question that, hey, there is a strategic content on platform, Moz, Instagram, they make a deal, get this content, right? Now, how do you understand the ROI of that content? That, I mean, okay, Amazon Prime in India is saying that, oh, I already have had a lot of like action movies in India. I don't have on Prime videos. I don't have like romance movies or something, right? Maybe I should invest that. Netflix is like, oh, actually, like, should I renew the series for season 2? Or should I kill the series and put money on another series altogether, right? Spotify is saying that, hey, Joe Rogan, I'm going to pay you 100 million. Why 100 million? Why not 80? Why not 120? Why Joe Rogan? Why not somebody else? They signed a deal with the Obamas for exclusive podcast, but why Obama? Why not Clinton? ShareChat, Moj, we signed deals with some of these creators. Why this creator? Why not somebody else? So this is an industry-wide problem. We have to understand the value of certain content to me as a platform, right? Now, how do we look at these values? One of the ways in which companies have been looking at this value is via survival models. So Spotify has bet heavily on that, to the extent that if you look at one of the recent investor presentations, there they talk about LTV models, lifetime value. Okay, what am I talking about? I'm talking about like value of content on platform. I have to understand that. And I was talking about survival models right now. Let me bridge the two. So I have a prediction model which tells me how long are you going to survive on the platform, right? Now what I can do is I can maybe remove Joe Rogan or remove this podcast from your life and then see, are you going to survive more or less? So I can look at the delta survival predictions, delta of the survival prediction, and that gives me an estimate of the value which this content brings to you as a user. So I'm not saying this is the state of the art way. I'm not saying this is published. I'm saying that this is one of the approaches in which you can start looking at the value of a content to some of your users. Now the question becomes, some content is substitutable, right? If you remove like Maggie on Amazon from one store, the other store is going to give me that. Not just Maggie. If you remove like one dress, maybe I'll get a very similar shirt from other retailer. So some content is substitutable, some content is not substitutable, right? So can I develop a substitution probability models, right? Separate models, and then look at the value of content in that way. That, hey, you know what? Like, I mean, you cannot replace Sehwag on a team, right? You can replace maybe a Dravid or some. I mean, I'm saying blatant statements. I'm gonna get flagged for that. But then some players are very crucial because they play a role. Are they substitutable? Are they not substitutable? And that defines the value which they bring. So how much money are you willing to give to that player, give to that content, give to that supplier, is depending on all of this, right? So, okay, that detour, the long story short is, there was a question which I forgot what the question was. Sorry, what was the question? Yeah, the long-term metric, right? Yeah, so let me stitch it all together and then wrap it up and then move on. The question was, how do we do this long-term, right? the initial question from Nipun was, are we looking at explicit signals or not? The long story short, from a detour was, we want to look at session level, like item level engagement, session level engagement, D1 retention, D7 retention, right? So long-term engagement, it was Professor Anubhav was asking about. My reply to that was, no, not just like long, like 1 month long, right? I want to look at 6 month long retention. For that, I need survival models. Then I went beyond and said, no, not just survival models. I need to understand the delta survival when I remove certain content. If I remove certain content, I just don't want to look at delta survival. I want to look at content substitution as well, package it all together, and then come back with an answer to my CFO that this is a value this contents bring to the table to the company. And here is why you should put in 8 million and not 7 million on this content, right? So there's a lot of ML problems which are not just about users. It's about how much money a company invests in certain content or not. So, I mean, every company has a budget. I mean, if you look at Instagram, if you look at Moz, if you look at ShareChat, all of these companies have account managers dealing with these creators. So you're spending a lot of money on supply. I mean, Netflix originals, right? I mean, Netflix has a big budget, more than like all these Hollywood movies combined on getting new series and new content, right? So there is a big amount of money there. How are you deploying that money needs that ROI calculation. It's not an ML problem in the traditional ML problem. These are more economics problem, econometrics problem, right? How do you do supply ROI? What's the return on investment on this supply? And again, there's going to be a diminishing return there. If I have 0 videos of crypto content on platform, the first video of crypto is going to bring in great value. If I already have 1 lakh videos of crypto, right? Additional 1 video is not going to bring much value. So I think like diminishing returns on the supply side as well. Cool. So this would have been another tutorial by somebody else in a half-an-hour slot on supply ROI, long-term survivals. But just because it got brought up, and I personally really like this problem space a lot because it's nightmarishly hard. And this is very, again, 5 years ago when I was in my like PhD, I did not know that ML is not just for 400 million users, 100 millisecond latencies, right? ML is also to make decisions on a company level way at the CXO level. The CFO can make some decisions on money deployment using your models. I'm not saying that Spotify uses them actually, but I think all of these do kind of form the way in which some of these decisions at the money deployment level get played out. Cool. Coming back, do we want to continue for 5 more minutes? And cool. So we're going to continue for 5 more minutes. I really want to wrap up this like candidate generation bit, and then kind of take a break. So where are we? We have looked at recommendations problem, multi-stage recommendations, right? And talked about some nuances there. One of the things I really highlighted was that my ranker cannot operate on millions of content. It can only operate on a few hundred thousands. And for that, I need a CG. And for that CG, I have this. So the next 5 slides, I'm going to rush through some of them because I'm way behind time. But I'm going to skip this for now. But essentially, right, I mean, the one of the candidate generators, which is very typically used in the industry, is this 2-tower model. So this 2-tower model says that it's a neural model for 2 submodels. One is this like user tower, the other is the item tower. And then there's a dot product, and then there's a label at this end. So what you can do is the label at the end is whether, again, any of the implicit signals you're talking about. Like, did you like it? Did you not like it? Did you comment on it? Whatever, right? You can design that label appropriately. Once you have the label, you can learn the embeddings directly. You can have some user ID embeddings. You can have some user features, item features, and then train this model. Let me share what happens next. So the way to look at some of these is I already have something like I maybe know your Android OS, maybe I know your Wi-Fi speed, I know where you're from, maybe you've taste onboarded, I know something about you. So there's a bunch of this content I have about users. Maybe there's a bunch of content I have about the candidates. Candidates are the content I have, 80 million tracks, right? So maybe I have the acoustic properties, maybe I have the genre of that. On short video platform, maybe what topic does it belong to? What's the image quality of this video? So there's a bunch of video signals I have. Now, what I can do is I can have this 2-tower model, which is gonna 1 tower for the user, other tower for the content, and then a dot product, and then train this model. Now, what we can do is like, we can train using implicit signal. Like if the user streamed a video for more than 3 seconds, it's a +1. If not, it's a 0. Now the negative, again, I'll have to do some negative sampling. So positive would be user watched the videos. Negatives could be like any other random video, which you want. There's a nice point here, which is, I think there's a lot of value in curriculum learning here, which is something which I, as a scientist, haven't explored yet. But like, how are you training this, right? look, it's very easy for me to differentiate between extremes. I know the user really liked it. I know the user really hated it. So those are easy for me to detect. It's like cat versus dog. But then what happens in between, right? Those are hard to identify because, hey, you stream for like 40 seconds. Did you not like it? Did you like it, but you had other things to do? If you stream for 1 second, I know you didn't like it. If you stream for like 2 minutes for the 2-minute video, I know you liked it. Anything in between, I'll have to guess. So that is where like understanding like all of this comes into play and how you're training this model. Curriculum learning gives you a way of deciding the curriculum, that do you want to go train on easy examples and then go hard, or train on hard examples and then go easy. My point is, again, you can do a very simple cross entropy loss and then train this model. Now, the best part is what happens to this, right? The output is, again, I don't care about the inputs here, right? I mean, here, you start seeing, I don't care about the inputs. I care about this layer here. The final embedding from the user tower, from the item tower, I can extract that and then save it to my database. That is the embedding which I will use for all recommendation tasks. So this is where, like, I mean, I said that, hey, the latent factors on the matrix factorization, I can store that embedding. Or the word-to-vec embedding, I can store that embedding. So these are the embeddings which we end up storing. And again, once I have these embeddings, I can train this model, right? I'll train it maybe on like last 2 weeks of data. But this is an inductive model. Now, you wouldn't have heard what an inductive model means. I'm not going to explain that, at least right now. I'm going to maybe talk about it later. But once I have this neural network trained, any new content I have, I can pass it through the network, extract the embedding here, and then try to recommend based on that. Now, this is where things get really interesting. The stored vectors, right? I mean, you have this, right? I mean, essentially you have the user tower, you have the item tower, you have these embeddings, and then you store the embeddings essentially, and then start using them for recommendation tasks. This is what happens at Twitter. I mean, again, this 2-tower candidate generator, right? I mean, this thing is fairly common. It's used at like almost all the companies I know of, including YouTube, including Twitter, Pinterest. So the example of 2-tower model for Twitter is like this. They have the consumer tower, they have the producer tower. So you have features like geolocation, topics, interested in, follow, favorites, and you have the other user as well. And then you can start training them using some training data. There's a nice blog post from Twitter engineering on this. Same for Pinterest, right? You have a lot of users, you have some pins, you have user features, you have a neural network there, you have pin features, you have sparse dense neural network there. And then you get these embeddings from the user tower, you get the embeddings from the pin tower, do a dot product, train on this model. Once you've trained it, then this is what you start using for real-time retrieval. Now, this is where things get really interesting. Now imagine this, right? I have this network trained, right? Now I want to use it to extract embeddings of 80 million tracks or whatever, like 1 billion pins. Now I can save it. I mean, 1 billion vectors saving, that's not a problem. You can save it on your laptop as well. The question is, like, if I have these 1 billion or 100 million items embedding stored and I have a user, now I want to find out the top 10 or top 1000 items for this user. Now, how would you do that? You do a dot product, right? Very simple. But dot product of 100 million items is a long time, right? And I want to do it in under 10 milliseconds. Why? Because my entire stack has a latency requirement of 100 milliseconds. So this is where a simple dot product, if you're going to write a for loop, right, then you are on your way out from the company. That doesn't work. That doesn't scale. What scales is something called approximate nearest neighbor search. So there are libraries. Again, I wish I had time to go into detail of this, but I really, really recommend you look at not just FIRES as a library, but look at the code design here. I think one of the things which people really underappreciate is the excellent code bases companies have and the case studies people can do on just system design by following along how they develop some of these very nice scalable architectures. Again, from that world, let me come back. What's going on? What's going on is that, hey, if I have these 100 million embeddings, I know a for loop dot product on 100 million is not on scale. So then I can do some approximate nearest neighbor search. What they will give you is they will give you in 2 milliseconds. You can kind of index it. They're going to do some indexing. They're going to do some approximate neighborhood match. Look, if you're doing a dot product is just a nearest neighborhood search, right? The exact dot product is very costly. The approximate dot product is very scalable. So that's the long story short. And Fires is a library which does that. You can find the details later. We also had a corresponding version called Annoy at Spotify. This was Spotify developed. So, and again, like, I mean, Annoy also has a actually like approximate nearest neighbor, OA. So that's the full form for Annoy. Again, ScanNN is one of the things which we use at ShareChat, and ScanNN is developed by Google. So there is no company out there which is not using approximate nearest neighbor. And you can start, I mean, literally, you have a bunch of these embeddings. You can start doing dot products in literally half an hour to 45 minutes, right? You can at least tick mark this engineering principle when you interview or when you go to a company. It's there in one of the notebooks, which I might share with you later. But again, this is like a very easy to follow tutorial. Yeah. So yeah, the great question. I think the question is, what does it do, right? What's the approximate nearest neighbor doing? So what's my problem? Let me take a step back and make sure I convey this well. I've trained a candidate generator. I've trained this neural network model on that dot product. That dot product will give me whether the user is happy or not. And I can train this end to end. Once I have this model trained end to end, I save this model. Now what I want to do is I'm the home page and I want to start recommending some items to you. I have 80 million items. Now you as a user come in, right? I want to generate a bunch of candidates for you because we're talking about candidate generator where we want going from tens of millions. I want a few thousand candidates. To do that, what I can do is the simplest approach. I have the user embedding. I have these 80 million items. I can do a dot product, pick up the top 1,000 and show that. Now this top 1,000, what you'll do? You'll do a dot product for each of these, right? And then pick up the top. So that order of 10 million or 100 million is insane, and that's not scalable. So exact k nearest neighbor search. This is k nearest neighbor, right? I have the embeddings. I have saved these embeddings. I can do the dot product, get the top k. But this exact top k is not scalable. So what people end up doing is they do an approximate top k. And this approximation has a guarantee that, hey, this set is going to be very similar with some guarantees on if you had an infinite compute, if you were to do this entirely, then you're going to get this set. Now the set I'm going to give you is approximately going to be the very similar, and there is some nuances on how I do it. K nearest neighbor needs a? Yeah, I mean, oh yeah. So K nearest neighbor, yes, I mean it does. I mean, I'm not specifying the measure here, right? Because the measure is a dot product here. So I mean, it's L2 similarity or cosine similarity or whatever. No, so this is approximate. So you're specifying the measure. You're approximating on the items you recommend, items you select, right? So I mean, again, if I have to, if not this, right, I would just randomly sample, right? I cannot do it for 10 million. Maybe I can do it for 1,000. So I'll randomly sample 1,000 and give that. So again, like it is k nearest neighbor, but it's incorrect because I'm not representing enough, right? So what it's doing is kind of giving you some correctness on the final output. But then you get to specify what distance measure you want. Right? You can do a cosine similarity, L2 norm, L1 norm, whatever you want, or even like some fancy measures. It scales better. So the only reason this exists is because we want to scale it to 100 million content and within 10 millisecond latencies. And the good part is like this, if you go to Files and it will take you max of 45 minutes to get it up and running on any content you want. So very, very nicely written. And you can start using it, right? I mean, like this is something which you go into any of these companies, there is if there's a company which is not using it, I would not recommend you going there. I mean, that's a blatant bad statement, but I think like most of these companies are dealing with large data and then there's no way around this. So this is where we are. I'm going to talk about rankers next. So I think we can happy to take a break now. Cool. I'm going to do one thing at least. I'm going to but at least summarize so that you know where we are. We're a long way behind, but cool. I mean, to be honest, the only reason I bring this up was to show this nice animation I have. So this is a take-home message, at least for a while. That we've talked about traditional recommendation systems, right? I mean, that matrix factorization, a bunch of that. We've talked about the modern stack. The modern stack has multi-stage pipelines. And then we talked about candidate generators looking at two-tower models and approximate nearest neighbor search. What's going to come next are rankers, multitask bandit-based, and some multi-objective ML for marketplace. So that's it. And the one last slide, and I'll let you go off for food and snacks. And I think you can guess what my slide is going to be about, right? So the slide is this. Cool. Thank you. And I think we are off for break now. So people online, we're going to come back in like 15 minutes. So like 11. No, 15 is good. Yeah, 15 is good. Yeah, I'm good. Yeah, 15 is good. Yeah, let's meet back at 11:05.
Okay, sir. Thank you.